So if all we have is this, the transformations inside, the shifting inside our function, is this going to refer to vertical shifting or horizontal shifting? Okay, so the value of x that gives you a 0 here is your horizontal shift, which is going to be your vertical asymptote. So our vertical asymptote is x equals 1. So that would be the first thing that we sketch. Okay, when you're asked to sketch these, it's just like with the exponentials. You're going to plot your asymptote first, and then you're going to plot your 2 key points. Okay, so let's find our key point. So the first key point is the value of x that gives you a 1 inside here. So what value of x gives you a 1? 2. So there's our first one. When we plug in a 2 here, 2 minus 1 is 1. 3 to what power is equal to 2? 0. So we have 2, 0. There's one of our key points. And then the second key point is the value of x that gives you an input b. So what value of x here will give you an input of 3? 4. Okay. And so 4 minus 1 is 3. 3 to what power is equal to 3? 1. And so those are our 2 key points here. And so we look at 4, 1. And when we sketch this, it's going to form our graph that looks like this. Okay. Again, I'm going to go through a number of these for the individual pieces. Then I'm going to have you try the ones that kind of correspond to all of them. All right, so when we look at this, we can identify our domain and range. The range for logs is the exact opposite of what it is for exponentials. It's all real numbers. And the domain is limited by what we can see in our graph. It's our vertical asymptote 1 to infinity, unless it gets reflected across. And the only way to reflect it across this asymptote would be a negative inside our function. So if there's a negative applied to the x in the input, then it would be different. Otherwise, it's the asymptote, vertical asymptote to infinity.